Good afternoon. Today we'll discuss about correlation analysis, and it is one of the most popular statistic tool to use to access the association between two variables. So it is used in many fields like social science research, data analytics, and also in management research, where researchers or managers wants to know how two variables are associated with each other and how much they are associated so that they can take any managerial decisions, or researchers can find out some solutions based on the relationship. So, to know this association and how much or at what degree the two variables are associated, to know all these, we use correlation. So, in today's session, we'll discuss about concept of correlation and how do we perform correlation in Excel and Python within Google Colab. So, what is the concept of correlation? Correlation refers to association of two variables and also strength of the association. So first, correlation tells about how two variables are correlated with each other and also the strength of the association. So means it will give a value so that we can interpret that how much two variables are correlate with each other. Correlation coefficient is the measure to which means measure which tells the association between two variables, means the number we will get by calculating correlation to measure how much two variables are associated, that can be expressed in the term correlation coefficient. So apart from correlation, there is another technique called chi-square, which also tells the correlation between which tells the association between two variables. But chi-square test has two problems mainly. It has no upper limit, means the chi-square value can be maybe 100, like that, and it never indicates how two variables are related, means there is no sign or no certain uh, no parameter is there to judge how these two variables are correlate, means it never gives you any direction, neither it's means two variables are positively associated or negatively associated. And Pearson correlation, which is the most popular correlation technique used by researchers and analysts, which measures the degree to which there are there is a linear relationship between two variables, and very importantly, the variable should measure with a continuous scale, maybe in an interval scale or a ratio scale. But in chi-square, uh, there the variables are categorical and they should measure in a categorical scale. And sample correlation ranges from -1 to 1. Why it is called sample correlation? Because if we calculate the correlation of population, then it is called population correlation. And we are always interested for the sample correlation, and it's simply known as correlation coefficient or Pearson correlation also coefficient. So I hope all of you understand the concept. So next is how this correlation looks like in a scattered plot. So when it is a perfect positive correlation, you can see the graph is means upward, and this is perfectly correlation, means the data points are tightly fitted around the line. So this is called perfect correlation, and here the correlation coefficient value is 1. Then if we move to second one, perfect negative correlation, the graph is downward and the relationship is negative, and the data points are also packed near to the line or on the line. And here you can see there is no trend line. Neither it is upward, neither it is downward. The data is scattered. So there is no correlation exist. Means here the coefficient or the correlation coefficient value is 0. Then if we move to moderate positive correlation, you can see that the uh, the data points are means gathered or just packed means as compared to the perfect positive correlation, they are packed loosely, but they are packed in a means certain trend line, and it's also a upward trend line, and we can say that it's a moderate positive correlation. Maybe it's nearly equal to one, but not equal to one. And here you can see the next the trend, the data points are packed, but not like perfect negative correlation, and it makes a downward graph or downward trend. So maybe the correlation is nearly -1. So left hand side, this is means perfectly correlate, perfectly positive and negative correlation, and right hand side we have moderate positive and negative correlation, and in between that is zero correlation, means there is no correlation or there is no association exists between two variables. So how to calculate correlation coefficient? This is very important. So before we calculate correlation coefficient, we need to calculate covariance. So what is covariance? Covariance is same like correlation, and it is the reasonable measure of association between two variables. Means we can say that covariance is the unstandardized form of correlation or unstandardized form of association between two variables with a particular means direction and with a particular uh, means the particular number which tells the strength, but it is unstandardized. First we need to identify what is the population covariance, then the sample covariance, then standardized sample covariance to get the correlation coefficient. Because what I said, the covariance is the unstandardized form of correlation, and we need to standardize it to find out the correlation coefficient. So let's understand with this very simple example. Here is the sample covariance. For example, sample covariance means that is the covariance divided by n minus 1, means you this parameter, this calculation x means summation I is equal to 1 up to n, then xi minus x bar, y minus yi minus y bar is the sample. uh, this is the population covariance, and when divided with n by n minus 1, this is called sample covariance. Okay, and when this sample covariance divided by the standard deviation, then we can say that it is the standardized, means that leads to r, means the correlation coefficient. Why standard deviation? Because when we measure two variables, maybe there is a high chance that, or most of the time, the variables are measured with two different units. For example, let's say advertising spend and sales. So advertising spend maybe in, let's say, maybe in millions, but your sales maybe in, let's say in thousands, for example, or in lakhs. So there we need to standardize both. Maybe for example, let's say if you want to know the, let's say, how the farmers using the fertilizer amount and what is their yield. So yield is calculated in a different way or different unit, and the amount of fertilizer is applied in their field, that is also a different one. So that's why there need to be standardized so that we can get a standardized number or standardized coefficient. So that's why with the sample covariance, we divided the standard deviation of x and y, or standard deviation of two variables, so that we can standardize it. So what is the takeaway? If you want to calculate the correlation coefficient, then first you need to calculate the covariance, then divide the covariance with the sample so that you can get the sample correlation, and then sample correlation should be divided with the standard deviation of x and y so that we can standardize it so that we can eliminate the different units. Otherwise what happened, it leads to means unbiased correlation coefficient. So next here it is the example. First let's say it's a very small data set. X is equal to 246 and y is equal to 135. So first we need to calculate the mean, then we calculate the deviation for x and deviation for y, and first we need to calculate the covariance. So this is the sample covariance we calculated, right? Then sample covariance, let's say sample covariance is 4. Then we move to the what I said. If we want to calculate the correlation, then we have to divide this covariance with standard deviation of x and y. So we calculate the standard deviation of x and y. So here it is. Let's say the 4 is the that is the covariance of sample covariance is 4, and standard deviation is for x is 2, and standard deviation for y is 2. So it's 1. So it indicates that it's a perfect correlation. So this is the concept, or means this calculation actually run behind the software, whether you are using Excel or Python. So it's very difficult to calculate by hand. So we can always rely on software packages that is available. So let's calculate with the Excel. So here I have calculated previously. So first what we do, we first uh, to calculate in Excel correlation, I have taken two data. So here is the farmer data. These are the farmer ID, and how they are using the fertilizer. It is maybe it's in quintal. Let's say 10 quintal, 14 quintal, and that is the second variable, that is the yield. Maybe 23 quintal per acre. So if you want to calculate the correlation, then first we use the correlation function in Excel. So that is correl, correl, right? So you first call the function. Then we first select the variable, that is fertilizer. So I've selected all. Then second variable I want to select, so yield. So enter. So how much? This is 0.3943. So this is a number which means what is this is the correlation between the fertilizer applied on in the on the field and the yield. So here we can say that this is the correlation, and this is positive as well as 0.39. So we cannot say that it's a very strong relationship, but some association or correlation between exist between fertilizer and yield. So it's a positive, means maybe the correlation is 0.39. It's very small correlation. So that's why in this way you can calculate different types of correlation. So next, let's do it in Google Colab. How you can use Python to do this. So first, to do this, we just use a simple function. Sorry, simple library first. First we need to import pandas library as pd, right? Then we first create a data set, because so we need data, right? First is the, let's say our data, let's say data is equal to, so how you can start, you can use a library. So library means, for example, library means you start with this curly bracket, then x, this is the first column. I want to take, for example, let's say x. So this is the, because here I don't use any data set, but I want to use the data, use means I want to create my data. So I will create a list. Sorry. So here I can, let's say, put any number 12, let's say 13, 43, 45, 46, like that. Okay. Then I will take another column for the variable to, let's say, y. So here it is y. So then again I will create a list. So let's say 23, 12, 32, 13, or 12. For example, we'll take just this one. So then we first convert into a data frame. Data frame means in the form of Excel, for example. So data frame df is equal to pd dot data frame function. Then simply I will put the data I have created data, right? Then I will calculate the correlation. So in Python, we can calculate the correlation with the function mm, core, COR. So correlation is equal to, let's say, df dot CORR, right? So simply correlation means it will by default take Pearson correlation. Then I will print correlation. So I want to save my correlation value in the variable that is called correlation, this one. So then I will print it correlation. So here you can see the correlation, right? So between x and y, the correlation we have found that 0.030849. It's very negligible. For understanding, for the sake of example, I have explained. So in this way, you can do the correlation by using Google Colab and Python. So thank you. So this is from my side, and I hope you understand. If you have any specific doubt, then you can put the comment. And if you like this video, then follow us and like and subscribe this channel. Thank you.